Okay, so we want to represent a 3D object on 2D media, in this case, drawing paper. Uh, it's the same as in computer screen too. Like it's a flat area. So 3D object is projected to a flat area, paper, and there are many different ways of how you can do that. And one of the things we want to talk about today is perspective projection. So, perspective projection is very similar to how you look through your eyes, and then maybe also the camera also is also similar. So, you have your eyes, and you see the trees, and then that image is uh, formed on your retina, on your eye, and actually it's like upside down image, and your brain processes it. This process is quite complex. So we can simplifies it by like this on the left hand side here. So you have a tree, and let's say you have an imaginary vertical plane, then you can see through, and then your line of sight going from the eyes to the tree, and that image is formed and that at that image plane. So depending on the distance from your eyes to the image plane, you see the size of the tree varies, right? Uh, if the image plane go back and forth, your image size will change. So this is how it works, your eyes and uh, cameras. So the one important thing is in perspective projection, the object is closer to your eyes, and you're gonna see that very big. And if as the object goes far away, the same object will look smaller. Okay, so in this case, on the left hand side, you have an airplane that looks relatively small because the plane is farther. And then also the width of the building here and the top should be the same width, but the lower part is smaller and a larger part is narrower. That's because of the perspective projection. And you have the railroad here on the right hand side. The width is wider as it closer, but as it go farther away, the width gets smaller and smaller. And in fact, these tracks are parallel to each other, never ends, but it looks like they are like converging to a point. Okay, so later we call that as a vanishing point. We're going to talk about it soon. So these height should be all same, but they also get smaller and smaller as they get farther from your eyes. So the advantage of this perspective projection is from this 2D image, you can perceive a 3D depth, right? So your eyes are trained such that if the same object is larger in your eyes, then you can perceive that it's a closer object. The same object is smaller, and your brain processes it, and it can almost estimate how far that object is, right? So that even if it's a 2D picture, you get some 3D perspective. Uh, you perceive some depth of the from the picture. So any drawing is made in the perspective projection, it looks quite realistic. It is as if you take pictures, so you can see the kind of 3D perspective. You can perceive the object. I can see. So like architects use this perspective projection when you sketch a building and you want to like to be more realistic. That's how you're going to use the perspective projection. So the object size depends on the distance from your eye. So in this case, in this building, this height and this corner must be the same as the height in the way back there, but the height difference is quite different in this picture. Okay, that's how you can perceive the depth information. But let's say if you want to build this building, And it's going to be really difficult, like for instance, this window here, and how going to estimate the size, width and height and of this window. And that because we have to know all kinds of information how to measure the width and height from this picture, because the angle is different. Angle is you have to know the angle, and you have to know where your camera is located, and what is the orientation of the camera, and what is the angle of the object, and how far that object is from your camera lens. And you have to do a quite complex calculation to compute the width of this window, because each window width is different based on where it is located, and it's also its orientation. So it is very difficult to know, like measuring from this picture what each object distance, the length is. So this kind of projection is not appropriate for manufacturing purpose in mechanical engineering. So perspective projection is not really used in mechanical engineering, but it used a lot in other industries, like for instance, uh, uh, interior design. They want to show more realistic pictures, architects, and there are other areas that is used quite a lot, but just not in mechanical engineering, where the precise measurement from the picture drawing is very important. Okay, so today we talk about this perspective projection just for today, and the rest of the course will never use the perspective projection. Okay, but I think it's very important to understand the difference between the perspective projection and the what's called orthographic projection. That's the what you're going to use, uh, because if you draw any object in orthographic projection, which is a mechanical engineering drawings, it kind of look a little bit different from what you actually see, because this perspective projection is more closer to how you see through your eyes and then cameras. You're kind of familiar with how things are look if you see that perspective projection. But if you see a drawing using orthographic projection and engineering drawings, sometimes it's quite looks kind of weird, because that's not how you see through your eyes. There are some differences. So I think it's important to understand what are the differences between the perspective projection and orthographic projections. Okay. So orthographic projection, we're going to talk about that on next time. I mean, the whole semester we're going to talk about that. So let's look at more further how the perspective projection means, how the perspective projection works. So to do that, we have to understand what the horizon and vanishing points. So here, we have this railroad track at the bottom, and you're standing here. So you're standing here in the back, and this is your eye position, and you're looking straight on. Right? This is a view direction going straight on. Uh, and then we have this imaginary image plane. Okay, so that is like perpendicular to your eye direction, and it's standing vertically in front of your eyes. So let's say this is like a made out of glass, so you can still see through things. And then your in each point of the track, you can draw a line between your eye and that position, a point on your object, and then you can mark projection point on that image plane. So from that point, you have that image is there, and also we can look at different color on this point will be projected there, and let's say this point will be projected there, and so on, right? So if you connect those lines, right? So there are millions of such points. You can connect it like infinite number of points. You project it, it's going to be just this line. And that same thing happens on the other track, and that will form this line too. Okay. So those two lines actually will meet at this point on the image plane, which will be on this your line of sight in this view direction. Okay, and we call that a vanishing point. So this happens because this railroad track is perpendicular to the image plane. So in this particular configuration, so this railroad track is direction is parallel to your eye direction. Okay, this is it is that particular configuration. In that case, that vanishing point is right on your view direction, the line of sight line. Okay, so that's why we earlier saw that in the picture. This is how we're going to look at it. Okay, so this railroad track is kind of parallel to your eye direction, and this is actually your eye position. Okay, so this is your height, and this is where you're looking straight on, in this case, camera. But those lines will meet at the point, and that will be the vanishing point. Okay, so this is a very important relationship, how it works. But so what if the railroad track is not parallel to your eye direction? It goes like this, okay? So then you're going to have a different vanishing point on different location. But the thing is that these two parallel lines, if these two lines are projected onto this image plane in perspective projection, it'll somewhere meet at that point. Okay, so yeah, this doesn't pen doesn't really work quite well. It doesn't have to respond very well, but it's just not that point where your line of sight is somewhere else. But these two track, yeah, this this track projected onto there. It's not really their real projection, but so here that vanishing point is somewhere. So the in the perspective projection, if you have two parallel lines in 3D space, any direction, two parallel lines, if you project those two lines onto the image plane using perspective projection, in that image plane, it'll meet at some point. It's on vanishing point. Okay, so the actual object line on 3D, they are, although they are parallel lines that never meet, but if they are projected onto the image plane or your paper, then those two parallel lines in that image plane space it's no longer a parallel line. It's going to be they're going to meet at some point. Okay, so that's how it works. So here, like in this case, you're looking in parallel direction with the road. Okay, and then these two lines will meet at the vanishing point, and this is your line of sight. That vanishing point is right on your line of sight, and this is your horizon. So this line, the horizon line, where that horizon is located, it's because of your height. Okay, your height determines where the horizon line is. If you're taller then or shorter, then your horizon line will move vertically. So that gives you a different view direction. So here we say worm's eye view. So that means you're very short. Okay, so almost like on the ground, your eye level is almost like a ground, and then the object you're gonna see more like bottom side of the object. Okay, and if and then that means that this is your paper. Okay, make a drawing of paper, and then your horizon line should be like lower part of the paper, whereas this bird's eye view, your eye elevation is quite high. Okay, you're very tall, and you're very taller than the object you're interested in, your drawing. Then you're gonna see more like a top side of the object, and your horizon line will be higher than that, the object. Okay, and then there's a humanized view like your maybe your house, like some part of your house is lower than your eye elevation, but the other half, like roof area, is higher than you. So in that case, it's a human's eye view. Okay, So depending on your elevation, actually the relative location of the horizon changes. And also where that vanishing point is. One other thing is the vanishing point, what we are interested in is the vanishing point on the horizon line. Okay. Like I mentioned, there are like infinite number of vanishing points. So any two parallel lines will have its own vanishing point on the paper. But the particular vanishing point we are interested in is the vanishing point on the horizon line. Okay. So in this case, there's a vanishing point on there. Um, but its location, you can kind of slide your vanishing point left and right on the horizon line. Depending on where that vanishing point is located, its kind of orientation of the part is rotated. Okay, so in this case, vanishing point is to the right of the horizon line, and you'll see more like this side of the object. And if the vanishing point is moved to the left, and you'll see the more like a back side of the object. Okay, so kind of a rotating the object. So when you want to draw, yeah, there are more things. So, like I mentioned, there are like infinite number of vanishing points, but you can't just use any like infinite number of vanishing point in making sketches. So, usually, we are using one of these, like 1 point perspective or 2 point and up to 3 point perspective projection. So 1 point is that point is on the horizon line, okay, like in this case, and then you can use 2 points on the horizon line. So when it comes to the 3 points, well, we can't use the 3 point on the horizon line because 3 points on same line is not going to make any object, right? They're degenerated triangle, okay? So that third point has to be somewhere out there, okay, not on the line. So those 3 points will make up 3 point perspective projection. So you define those vanishing point before sketching the object, and then you sketch the object based on the vanishing points.